Welcome to This Explainer. I am absolutely thrilled you're joining us today because right now we are embarking on a highly specific, high-stakes tactical mission. Think of yourself as a secret agent for a moment, and your mission objective is simple but critical. We are going to extract maximum possible marks from the Cambridge AS and A-Level Physics 9702 exam. Specifically, we are going completely tactical on that foundational yet notoriously tricky area: physical quantities, their magnitudes, units, and estimates. Now you might be thinking, hey, that's just Chapter 1 stuff, right? But here's the thing. This topic appears in literally every single examination series. It's the bedrock. So treating this like a tactical extraction mission isn't just a fun metaphor, it is quite literally your blueprint for exam survival. We are going to break down exactly how the examiners think, how they construct the paper, and most importantly, how you can strategically pull every single point off that page. Let's get right to it. Okay, let's dive into this with a massive reality check directly from the people who actually grade your papers. Every year, the principal examiner reports consistently highlight a massive trap that students fall into. Let me read this to you. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. This quote right here, this is the ultimate key to your exam survival. So many incredibly smart students who know the physics inside and out, do the math in their heads, scribble down a final numerical answer, and just move on to the next question. And they're leaving points on the table. It's heartbreaking. If you do that, you're playing a dangerous game. If you make one tiny arithmetic slip on the final line, you get 0. But if you show your process, the examiner can step in and award you points for the method. We are going to fix this habit today, for sure. So, here is our systematic game plan for today's mission. 1. Core principles and concepts. 2. The procedural framework. 3. Critical examiner warnings. And 4. Evaluation and exam strategy.
Let's start with Section 1, Core Principles and Concepts.
Top-performing students don't just rely on rote memorization. They just don't. The Cambridge syllabus prioritizes analytical depth over superficial breadth. What does that actually mean for you sitting in the exam hall? It means the examiners are going to intentionally throw you into totally unfamiliar contexts. You're going to open the paper, look at a question about estimating physical quantities, and think, I have never seen this specific setup in my textbook. And that is exactly the point. They want to test if you can adapt your core knowledge to scenarios you've never encountered before. It's a test of agility. You need to be ready to apply the foundational principles of magnitudes and units, no matter how strange or complex the setup looks on the surface.
And that brings us directly to the assessment architecture. To navigate those weird, unfamiliar contexts, your theoretical foundation needs to rest on these 4 distinct pillars. First up, you need precise definitions. Sloppy language is simply not allowed. You have to use the exact phrasing the syllabus demands. Second, you must understand causal relationships, meaning exactly how changing one physical quantity impacts another. Third, you need logical, structured reasoning in your explanations. But the fourth one? That is your secret weapon, cross-topic connections. The principal examiner reports specifically highlight that candidates who successfully reference cross-topic connections achieve significantly higher marks. It shows the examiner that you understand physics as one massive unified system rather than just isolated, disconnected chapters. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving on to Section 2, the procedural framework. All right, this brings us to what I consider the core law of the Cambridge exam universe, the method mark strategy. This is the absolute art of earning marks by explicitly demonstrating your structured analytical process. Remember that quote we looked at right at the beginning? This is where it comes to life. The examiners are demanding systematic processing. You have to literally show the examiner your exact thought process on the page. By taking the time to do this, you secure those vital method marks. Think of it as an insurance policy. Even if you make a tiny calculation error right at the very end under the pressure of the clock and your final magnitude or unit is slightly off, your method marks are locked in. You survive the question. So you're probably asking, what does a perfect point scoring process actually look like? It looks exactly like this: the deconstruct, solve, evaluate sequence. When you are tackling questions on physical quantities, you need to standardize your attack plan. Don't just wing it. First, scan the prompt and identify the key elements and given information. Second, deconstruct it. Break the problem down into logical steps and decide on your analytical framework. Third, execute your analysis. Solve it systematically with incredibly clear working.
Fourth, verify your results. Take a step back and ask, does this estimate actually check out for reasonableness? Does this magnitude make physical sense? And finally, if the question asks for it, make justified recommendations based on your findings. This is the exact rhythm and flow the examiners are desperately looking for when they grade your paper.
Now, what's really fascinating here is how strictly examiners enforce what might seem like simple presentation conventions. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, back to the conventions. When you are interpreting data, extracting values from text and tables, or just writing out your sequential steps, you absolutely must adhere to these rules. You need proper and explicit headings. You must use correct scientific terminology. Please don't use everyday conversational words when a precise physics term exists. You need appropriate formats for your data presentation. And above all, you need clear and logical annotation of your working. It's a simple formula. Messy papers, draw marks. Pristine convention-following papers, pick them up.
Let's move to Section 3, Critical Examiner Warnings. We are now going to look at the top 3 mistakes pulled directly from examiner reports, starting with mistake number 1, relying on vague generalizations. This is huge. Average students drop massive points because their answers are just too fuzzy. They write these sweeping statements, hoping to catch a mark by accident. But the academic benchmarks require logical, structured reasoning. Examiners are actively hunting for specific, concrete details in your analysis of physical quantities. If you find yourself writing a generic physics statement that could honestly apply to 10 different questions on the paper, stop immediately. You need to narrow your focus, zoom in, and provide the specific analytical depth they're actually asking for. Mistake number 2 directly violates the procedural framework we just discussed a minute ago, forgetting format and presentation conventions. The examiners explicitly, repeatedly note this in their reports. Messy working, forgetting to include the correct units on your physical quantities, skipping clear notation, these errors immediately trigger marked deductions. It literally doesn't matter if your underlying physics knowledge is genius level. If your presentation format is wrong, you lose the points. The examiners shouldn't have to solve a puzzle just to read your handwriting or follow your logic. And the third top mistake we see over and over, answers that are not specific to the context given. So, the absolute crucial point is this. You cannot just brand dump raw physics facts onto the page and hope for the best. The assessment objectives specifically target your ability to apply and analyze. Therefore, your answer must directly address the very specific scenario outlined in the question prompt. If they ask about estimating the magnitude of a force in a very specific mechanical setup, your answer must be perfectly tailored to that exact mechanical setup, not just giving them a general textbook definition of force. Context is everything. Finally, Section 4, Evaluation and Exam Strategy. This right here is where we secure those elusive, higher-order marks that separate the good grades from the absolute top-tier grades. To hit the highest evaluative levels, you have to be able to judge the quality of the evidence and the data you are working with. This demands a highly critical eye. First, you need to explicitly identify the limitations in a given physical measurement or estimate. No measurement is perfect. Tell them why. Second, you must clearly note any assumptions that were made to reach a conclusion. Third, you should be prepared to offer alternative interpretations of the data. And finally, critically assess how those alternatives would actually affect the final conclusions. Comparing different approaches and making justified recommendations is exactly what elevates your grade. Now, to handle all this complex theoretical information under the immense pressure of the ticking clock, our sources suggest a really effective memory hack. Use a visual story method to encode these concepts. Because the theoretical architecture rests on precise definitions and causal relationships, trying to memorize them as dry, boring lists is really tough, and it often fails when you panic. Instead, visualize the physical quantities. Create a mental, vivid story of how changing one unit mechanically impacts another. By encoding the data visually in your mind, you ensure that under exam pressure, you can quickly and reliably retrieve the exact definition and relationship you need. All right, let's lock all of this down. Here are your 3 absolute key takeaways from this explainer. 1. You must master the method mark strategy. Always show your working clearly and logically on the page. 2. Follow the deconstruct, solve, evaluate sequence strictly to ensure your processing is completely systematic. And 3. Avoid the top examiner's warning by ensuring your answers are highly specific to the given context, never relying on vague generalizations. If you apply these tactics, you are directly answering the examiner's core expectations.
I want to leave you with a final, provocative question to really chew on as you head into your next study session. If you rush to the final answer without explicitly showing your assumptions and your logical steps, are you really extracting every possible mark from that paper? Remember, the process is just as important as the destination in physics. Transform your approach, show your work, and take your points. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.